have problem number 11. I've drawn it up a little bit ahead of time. We have two forces acting on a 7-kilogram block. We got F1 acting downward at 70 degrees and F2 acting to the left horizontally. And we know the magnitude of each of these forces. We're asked to find out the acceleration, the horizontal acceleration of the block. All right, since we know it's going to accelerate in the x direction, it asks for the magnitude and direction. We can just, it'll suffice to say positive or negative since we know it acts along the x-axis. All right, so all we have to do is now draw our free body diagram, and we'll rearrange the way the arrows look, the force arrows look, because we're going to have this one acting as a pulling force, right? That's the way we always draw these. F2 over here coming from the body, right? And here we'll just bring this one down, all right? And this will be F1 acting at an angle of 70 degrees from the horizontal, okay? 70 degrees right there. Now we have other forces acting as well. Of course, we have the weight of the object acting downward, mg, and we would have some corresponding normal force acting upward, such that the vertical were all in balance, right? We would have the y component of force F1, and we'd have mg. Those would add up. This one and this one would add up to the straight up normal force, which is going to be balancing those out. All right. So all we're dealing with, though, is what's going on in the x direction. So we have the x component of F2, easy because it's just along the x-axis, but then we have the x component of F1 based on its angle with respect to the horizontal. All right, so now going to our two-equation strategy, we have net force in the x direction is equal to ma, acceleration in the x direction. It's all in the x direction, so I'm not going to worry about denoting subscripts. All right, so we also have net force is going to be equal to the x component of F1 minus all of F2. All right, so we look at it like that, and just using our two-equation strategy, we're going to get that ma is equal to F1x minus F2. All right, so moving further along, we have mass times acceleration is equal to all this stuff. So our acceleration is going to be equal to F1x. F1x is just going to be the magnitude of F1 times. Thanks for playing. It is the cosine. Cosine theta. All right, minus F2 over the mass of the object. All right, so now that we've got it all in terms of things we know, we just say the acceleration is equal to, the magnitude of F1 was what? 59?
Yes. Yeah.
Yes? All right, so 59 newtons times the cosine of 70. It doesn't matter, honestly, if it's plus or minus 70. We really would have put in negative 70, right? But they have the same cosine, right?
We have to do this.
Okay? Minus F2, what's the magnitude of the 33 newtons? Divided by the mass, which is 7 kilograms. Is that correct? All right. So 59 cosine. Can somebody crunch up those numbers for me?
A equals negative 3.
Oh, too many people talking. Kate.
A equals negative 1.83, but negative implies it's going left.
That is correct. All right, let's check and make sure our units are correct anyway. Newtons minus newtons is newtons divided by kilograms. Kilogram meters per second squared divided by kilograms meters per second squared. That's acceleration. So you are correct, Kate. That is that the acceleration, the magnitude is 1.83 meters per second squared. The direction is negative.